in the previous video, we learned what is graph, what are its types. Today we'll see how to initialize a graph or how to declare it in your own language. You would be given two params, n and m, as number of nodes and number of edges. Let's see an example over here. So we have 6 nodes and 5 edges. 1, 2, 3, 4 and 5. And as you can see, we have nodes from 0 to 5, that is 6 nodes. And then you will be also given what are the edges between two nodes. So like 0 has an edge with 1 and 2. 1 has an edge with 0 and 2. Similarly, 2 has edge with 0, 1 and 3. Now we should note one thing, if our nodes are 0 base index or 1 base index. So to initialize a graph, that can be done with two ways, with matrix or with a list. Let's see how to do it with a matrix. So if the index is from 0, we will take n as a size of matrix or list, and if the indexing is based on 1, like starting from 1, we will take n plus 1 as a size of list or a matrix. Now we have 0 based node starting, so we will initialize the matrix of size 5. We will initialize with 0 with a square matrix, with a 2D matrix, and then we will save, since it is an undirected graph, we will each edge as a unit weight. So wherever there is a edge between two nodes, we will set 1 over here as a unit weight. For example, if 0 and 1 has a edge, so what we will do, we will mark 0 and 1, removing 0, and we'll mark as 1. Similarly, 0 and 2, so we'll remove this 0 and we'll mark over here as 1. So whatever edges we have, we'll mark them. So our graph would become like that. If you see, it will be 0, 1, 0, 2, 1, 0, 1, 2. Let's see what are the steps to do this. As I said before, we will take a matrix, square matrix of size n, n. So step 1 would be initializing that matrix to 0. So we can have a function to initialize a matrix based on the number of nodes given to us, as initializing it to 0. Step 2 would be, since it is an undirected graph, we will the node u and v will have an edge. Similarly, node v and u will also have the same edge. So we will mark 1 on both indexed. This is for the undirected graph. Step 3 would be just doing it for all the edges given. So these are the basic steps for initializing a graph using a matrix, a square matrix. Now let's see how to do it with the other way. Let's see how we can also define a graph using a list. So with the same example, we would be given n and m, where n would be number of nodes and m would be number of edges. And the one thing that we have to keep in mind is, if the node starts from 0, the size of the list or matrix would be n. And if the nodes start from 1, we will initialize, or we will take the size of our list or a matrix as n plus 1. So this will be like our structure of our array list of array list, where we will have 0 to n or n plus 1, and over here we will store the other nodes connected to it. So in our example, since we have a edge between 0 and 1, 0 and 2, we can store as a first, initialize it with 0. Over here we can add 1, and here it will come as 2. So this way we will make a list of lists, storing the first list as the nodes and the list of lists, the second list, nested list, as the second nodes. Let's see how our list will look for the above example. So if you see, as I told, we have to initialize it with the nodes. So the first node has a connection with 1 and 2, so it will have list of 1 and 2. Say if we had over here a weighted graph, then we could, instead of using integer, we could have used a pair where first element would be the second node, where over here 1, and we can have the second element over here, the second element being the weight of the edge. Like for example, if I would have 3 over here, I would have stored 0 with 1, 3 as a pair. So since it is a unweighted graph, we assume that it has a unit weight, so we can have list of integers rather than list of integer and pair. Now let's see what are the steps involved in that. So again, we have to initialize the list according to number of vertices, where number of vertices or nodes is n. We will initialize our first list. Step 2 would be adding a list of e for each node. Since u and v, we'll append in the first list. So for example, 0 we'll append with 1. And since it is a undirected graph, we will also append 1 with 0. I will share the code in your respective language for this. This is just the steps that you should keep in mind. So step 3 would be initializing the graph and doing it for all the edges that we have. Okay, one thing that you have to keep in mind, what are the component of graph? If you see this example below, this is not one node and one graph. This complete set is called a graph. So a graph can have multiple components. Like this is one component and this is the other component. So for this, whenever we are doing anything, any calculation based on graph, whether it is traversal or doing any other calculations, we'll have to do it for the entire graph, not just for one component. So for that, we'll have a visited array where we can store as a Boolean visited array depending on number of nodes. So since we have 4 nodes over here, I defined an array of size 4 having it false. So what this visited array will do? It will do 2 things for us. One, it will help us traversing all the nodes, that is all the components of a graph. Second, it will prevent an infinite loop for a cyclic graph. Say for example, we started from 0, we can go to 2, then again we can go to 1, and when we will coming back to 0, it will prevent that infinite loop. So how it works is, we'll have a visited array defined as false, where each node we are not visited. Whenever we are visiting to any node, we will make that node as visited as true. So for example, if I go to 0, I will mark as true. Next, if I go to 2, I will mark 2 as index of 2 as true in the visited array. Then when I go to 1, I will mark it as true. Then I will have an outer function where I will check if every element in this visited array is true. So by this, I can go in all components of the graph. For example, I will use a loop with 0 to n, where n is number of nodes, to just populate in this array. So for example, I will check if visited is false, then we will have our logic. But if it is true, then we'll have to move it, to move inside. So if not visited If it is false, then we'll have to go in the logic. So for 0, 1, 2, since we have visited, this logic will not work. But next time when I will become equal to 3, since it is false right now, we will again go for this loop traversal. You will have a better understanding once we learn how graph traversal works.
Don't forget to like and comment, and if you are new to the channel, guys, please do subscribe to my channel.